That we are going to focus on is typically SMO question. So SMO is basically single mathematical analysis. Those type of questions which are usually used as template or as a model question for creating questions for the national poll selection as well as for the international poll selection in our country. Because of that, getting practice with this question is really helpful when it comes for the final exam. So we'll do this question now. And the question that we are going to choose to do, it's going to be the second question here. So the question goes by log in the base of 3 12 in the base of 16, adding both of them, and we are subtracting log in the base of 27 8. And we were supposed to simplify it and give the answer. The answer was supposed to be either 5 of them, and we were supposed to choose the correct answer. And the thing is, for the national poll selection, we all don't have an MCQ. We simply don't have an MCQ section. What we have is we have structured we have short answer questions, like 15 of them. Then we have 2 essays questions. So that's how the structure goes. But here it was like MCQ, but still you have to get used to the concepts. So because of that, we'll use this as a model to develop our proceedings or techniques around these questions. So what we can do, first of all, we can observe. We have to know certain specific things to actually be able to do this question. Here we can observe the log, the bases have a specific pattern, 3, 9, 20. All of them are powers of 2, right? So this is 3 square, this is 3 cube. And in logarithms, there are specific rules, or there are absolutely solid reasons why those rules exist. But to do the question here, we just have to know that those rules exist. And if we have done previous work, we would be around those rules, we would feel so confident on using them. If not, we may feel a little bit of doubts. It's good if you go again and work it out by yourself, like the rules, how they are made, why they exist. It would give us sure sense of confidence. But for the purpose of this question, we just have to know those rules exist. Right? So the rules is what it is about. When you have a logarithm, you can have a power in 2 places. You can have it in the base, this, in a position like this, or you can have the power in a position like this. Here it is in the base, it is just in the particular value. Right? That's a distinction. In both of these instances, there are ways to represent it in another by taking this base out of the logarithm part. How we can do so? If the power is in this value, you just have to take that 2 and you just have to put it in front of the log. So you get something like this. In case the base is in the power is in the base, you have to just take it as usual. But instead of just putting like 2, you have to invert it and put log 6. Would it be always correct? It would indeed be always correct. So that thing you can use, and it's a very fundamental thing to do. No, to do this question much smoothly and much without any sense of, or very least sense of distance. So what we can do here, we can write log 312. That thing you don't have to change because it's in the simplest base in the first place. The second thing what we can do is 3 is 2, then it's 16. Right? So you know if that's a 2, you can take it and write it like this. Just have to do the same, and it becomes a half log 3. Do you change this value? Obviously, you don't change this. So it's 16. Then the next, why we write so? First, it is 3 squares. Just take the 2 and we write it, invert it and we write it in form. And for the next part, it's 3 cube A. So we take the 3 thing and we invert it. It's 1 over 3. And we write the rest of the things as they are. So we get something like this. Now what we can do, we can observe when we have rules in logarithms. When we add logarithmic value or subtract logarithmic value, when you have a same base, you have an advantage. When the base is the same, if it is about addition, you can multiply it. If it is about division, subtraction, you can divide. But the thing is, here there is an extra value. There's a half, there's a 1 over 3. So we have some trouble. So what we can do so is just like the rules here say, the rule here says, if you have a power, you can take it out and write it in front of it. The other way applies as well. When you have a value in front of the log, you can just take it into the log and you can write the power. So if you have a half, you can write it simply as log 3. The 16 is the base and you can convert it to power of half. And the same applies for the next value as well. So you get log 3/8, 1/3. And in the first element stays as it is, because there is nothing in it. So you get something like this. What you can do now, the base is the same. So we were able to, we managed to convert the different bases into the same base. So now we can do something. So what we can do, since it's addition, we can multiply. So the base doesn't change. The 12 remains as it is. The 16 to the power half, which is square root of 16, is 4. So times 4, because it's a positive, it's a addition, we multiply. Then there is a division, so we're going to subtract. But we're going to subtract 8 to the power 1/3, which means the cube root of 8. So what is the cube root of 8? It's 2. So it's 2. So we can cut these things off. It's 6. 6 times 4 is 24. And the value comes out to log in the base of 3, 24. Is there such an answer? There is such an answer. So the answer would be D4 is particular.